Okay, continuing our review for the unit test we have coming up. Um, so this one, last year this topic was close to Christmas. That's why it's referring to one of Santa's elves. So Santa's elves may not occur on this particular test for you guys, but you can handle it. Consider the polynomial 2x to the fourth plus 17x cubed minus 90x squared minus 833x minus 392. The possible rational roots are this long list. One of Santa's elves was gracious enough to work his way through the list and do the two synthetic divisions below. Okay, so I can look at this immediately without much work and tell you that x minus 7 is a factor. Okay, I didn't have to do the work, somebody did it for me. I can look here and see that x plus 8 is a factor. Okay, so there was a fourth degree problem, and now I have two of the factors. So I know that P of x is equal to x minus 7, x plus 8, and then it has to be what you see there. That represents 2x squared plus 15x plus 7. So if I can just factor that, I'll be done. So 2x squared plus 15x plus 7. In order to factor that, I need two numbers that multiply to give me a 14 and add to give me a 15. So those numbers are 1 and 14. So this is 2x squared plus x plus 14x plus 7. Out of the first two terms, I factor in x. I'm left with 2x plus 1. Out of the next terms, I factor 2, and I'm left with 2x plus 1. So this is x plus 2 times 2x plus 1. So the final factorization of this polynomial is x minus 7, x plus 8, x plus 2, and 2x plus 1. And so if I look at this, now I'm asked to graph it. What is the degree? Easiest thing to see for the degree, that's a fourth degree polynomial. So the degree is 4. Leading coefficient, the number in front of x to the fourth is 2. Leading coefficient is 2. Y-intercept, best place to get that is right here. It's negative 392. So the y-intercept is 0, negative 392. The x-intercepts, that comes from my factorization. So my x-intercepts are 7, 0, negative 8, 0, negative 2, 0, and it looks like negative 1/2, 0. That comes from looking at all of my factors. There is no multiplicity here, so there's none, because none of those factors are repeated. So in order to graph this, let's find all of our points. So our points are 7, 0, 1, 2, 3, 4, 5, 6, 7. I'm going to cross at all of these points. Negative 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. That's right here. And negative 2, 0 is right here. And negative 1/2 is going to be right here. Okay, so those are my 4 zeros. Now this is an even degree and leading coefficient positive. I know it's going to look like this on both of the endpoints. Okay, and the y-intercept is negative 392, so that's somewhere way down here. So can I get to where? Can I start at the top, cross, 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 and then come down to the y-intercept and go up? Yeah, so the only thing this function can do, it starts up here, it's going to go down, it has to come up, it has to go down, and then it has to hit this point here, and then come up again. So that is the only thing this polynomial can do. It goes through all 4 of my zeros, and it has the end behavior that it goes up on both ends. Okay. Next says, write a possible equation of a third-degree polynomial with a negative leading coefficient passing through these points. Okay. This polynomial has a negative leading coefficient. I'm going to put a negative sign. And then it has to pass through these points. So it's going to have to be x plus 4, x minus 1, x minus 3. Okay. So that is a third-degree polynomial. It has a negative leading coefficient, and it passes through all of the points that you see right there. I'll keep on going. So we'll do 2 pages on this particular recording. So number 6, find a fourth-degree polynomial that has zeros at -3, -1, and 2. The graph does not cross the axis at x equal 2. Okay, so what I know immediately, so if I have -3, 1, 2, 3, so I know I'm crossing the axis there. -1, I'm crossing the axis there. And then I'm told at 2, I do not cross the axis, okay? So that means that I've got a multiplicity. So immediately, I know there's a multiplicity at 2. Now, this is going to be a fourth degree. When they give me this end behavior, that tells me it goes up on both ends. That's what this means. So that means my leading coefficient is positive. So I'm going to have f of x equal, I'm going to have x plus 3, x plus 1, and then x minus 2. If I do not cross the axis, that has to be x minus 2 squared. So multiplicity of 2 means I do not cross the axis there. And now if I can graph this guy, it's going to have to start up and go down. What I can do to double check this, what would be my y-intercept? My y-intercept is what I get when x is equal to 0. So I would get 3 times 1 times -2 squared. So that is 12. So it's going to have to go through the point 0, 12. So my graph is going to start up. So it's going to start up and go down. It's going to go up to this point 12. It's going to have to bounce and do this. Okay. So that's the only thing that this particular graph can do. So there, I had to use the roots, I had to use end behavior, and I had to use multiplicity to figure that one out. Number 7, I give you a polynomial in 2 different forms. And remember, there were certain things that were helpful about one form over the other. When I look at standard form, that's the easiest place to get the degree. It's fourth degree, negative coefficient. Y-intercept is 0, 10, okay? I did no math and I could figure that out just by looking. Those are great pieces of information to get from there. The x-intercepts, I needed in factored form for that. So the x-intercepts are -1, 0, 2, 0, and -5, 0. Okay, those are my x-intercepts. There is a multiplicity of 2 at x equal -1. So now when I go to graph this guy, let's see, I know I'm going to cross the axis everywhere but -1. So at -1, I do not cross the axis. I'm going to cross the axis at 2 and -5. So 2 is right here. -5 is right here. Those are the places I cross the axis. Y-intercept is 0, 10. Okay, fourth degree, negative coefficient. That means this graph is going to look like this. So the only thing I can do, I can start from the bottom here. I have to cross at -5. Okay, so if I cross at -5, and then I'm going to have to not cross at -1, I've got to go through this intercept up here, the y-intercept, and then back down to cross here. So that's the only thing the shape of this graph can do for us.